Welcome back. Previously, we gave each wallet a starting balance. The next step is to create the public key address for the wallet. This public key address can't just be a unique ID though. It has to be based on a cryptographic private public key pair. To create this key pair, we can use a module called Elliptic. Elliptic is a module in Node that contains classes and methods that enable elliptic curve-based cryptography. Elliptic cryptography is an advanced mathematical subject, but essentially, it centers around the idea that it is computationally infeasible and impossibly expensive to guess the answer to a randomly generated elliptic curve. Now, we won't be diving deep into the math of the system, but rather we'll be focusing solely on the private and public key capabilities of Elliptic. So to start, we can kill this running test, and let's install Elliptic with npmi, which is at version 6.4.1 as of this course. Cool. Now, I definitely recommend searching up the Elliptic Node.js module online and checking out its public interface. The key parts to look out for are how the key pairs are created and how the signatures are done, and how those signatures are verified. Alright, now that Elliptic is installed, let's include it in our project. To work with the Elliptic functionality, we're going to create an instance of the main EC class of the Elliptic module. EC stands for Elliptic Cryptography, and let's do that within a new index.js file within the util directory. So this is going to be the new default file for util. And in here, we're going to get a reference to the main EC class. So set this to an all caps EC. And this is the result of requiring Elliptic. And then this default export contains this inner.ec property, which is this overall EC class. Cool. Now let's make a local instance of this EC class. We're going to call this EC, but all lowercase. And this is going to be a new instance of that EC class that we required. Now, there are a handful of implementations for the elliptic curve algorithms, which we specify within the constructor of the EC module. But Bitcoin uses one called SECP25K1 or 256K1. So we're going to use the same one. Real quick, in case you're wondering, SEC stands for Standards of Efficient Cryptography. The P stands for prime, and 256 for 256 bits. In the elliptic-based algorithm, a crucial step is to use a prime number to generate the curve. And with the SECP256K1 algorithm, that prime number is 256 bits. So that's where the 256 part goes in. The K stands for Koblitz, which is the name of a notable mathematician who significantly contributed to developing this algorithm. And the 1 simply stands for this being the very first implementation. All right, back from that side note, let's export this EC class within an object for this index.js file. So the exports of this overall file is going to include our EC object. Cool. So let's now use this in the index.js file of the wallet class. Let's also require this EC instance after the starting balance. So let's grab the EC instance by requiring it from the util file that is located one directory back, or rather the util directory, which has the index.js file, which contains our EC instance. Now, this EC class instance is pretty powerful in terms of holding a lot of methods. For one, it contains a gen key pair method with the ability to create a powerful key pair object. So let's use that to create a local key pair for the wallet in its constructor. We're going to make a key pair constant, and this is the result of calling ec.gen key pair. Recall from the overview on wallets and key pairs that the key pair has two crucial aspects to it. It has the private key and the public key. So the private key again is used to generate signatures for the private key owner on pieces of data, and the public key is public in order to allow others to use it as an address in the cryptocurrency. Now, what's awesome about the Elliptic module is that all of this functionality is baked into this key pair object. So we can set a public key property on this wallet instance that is the result of calling keypair.getPublic. Cool. And as we save this, well, this should actually get past the second test where we're checking that the wallet instance does indeed have a public key present as a property on the instance. Now, as we do so, Well, you'll likely find an unexpected error in your running tests. All of a sudden, there's this module named BroRand saying that the random object can't be generated. Well, this is because the genKeyPair function relies on the BroRand module, which is installed automatically as a dependency with the elliptic module. However, BroRand bases its random object functionality based on the current JavaScript environment. Currently, Jest is configured by default to simulate the browser environment. But right now we're running in Node, so therefore BroRand can't be using the browser environment to base its random object functionality. So the solution is to tell Jest to acknowledge that we're running in a Node testing environment within the package.json file. Head to package.json. We're going to add a new section after scripts for Jest itself. And we're going to configure Jest with an object, or rather a pair of curly braces where we can specify that the test environment, so test environment is actually Node. And as we save this, in order for the change to be picked up, we need to completely rerun the test. So kill your running tests, and once you have that change, go ahead and fire npm run test. And as we do so, well, now we get a fully passing test suite, and there's no more error since a public key was successfully set. Cool. Now, one thing we want to do is we want to see what this public key looks like. So in the index.test.js file, let's console.log the wallet.public key within this test that it checks that it has the wallet.public key. And as we do so, we get this EC point business with an X and Y value. This is because elliptic actually returns an X and Y value that relate to coordinates on an elliptic-based curve in mathematics. Now, this is certainly useful, but what we need is a single value that can also serve as the address for the public key. And an option that we have at our disposal is to transform this public key into its hexadecimal form, which is a form that we're very familiar with in this project, since that is what we are using for our hashes. In the index.js file, let's make sure that this getPublic function also calls .encode, and we're going to encode it in its hex form. And as we save this, well, now the wallet.public key is a nicely formatted hexadecimal value. All right, very nice. So feel free to remove this console.log. Go ahead and experiment with the wallet some more if you want to. And great, now the wallet has a balance and a public key based on cryptography. Note that we're not making a private key field for this. Recall that it's crucial that this information should be kept private. So in this case, we're not even going to access it. There is indeed a getPrivate method on the key pair, just like the getPublic method. But it's dangerous to introduce code paths that could leak this information. So let's refrain from using getPrivate unless it's absolutely necessary. All right, the next crucial aspect of the wallet will be the ability to sign data. By signing data, this wallet will be able to conduct official transactions with other wallet owners in the system. Let's develop this overall functionality next.